Hey there, we'll be looking at our last example on network flow. And after this video, we'll be moving on to linear programming. Take a minute, read the question on the screen, and let's get right into it. So we'll just talk about the algorithm for solving this problem. The first thing is we'd have to create a source vertex, and let's call that source vertex S, right? As we've always called it. Then we create a sink vertex, let's call that T. Then for each kid, we want to create a vertex. For each kid, we want to create a vertex VKI, and we want to connect VKI to S, where the edge is capacity 1 because each kid can only go to one school. So the next thing we do is we think about it, for each school, we want to create VSI and then connect VSI to T, where the edge is the capacity U, that's the maximum students admitted to that school. Next, we want to connect each VKI to VSI. That means we want to connect each kid to each school with an edge of capacity 1 if the commute time from where the kid is to school is less than or equal to T. And we want to use the forward focusing algorithm to find the maximum flow in this network. The flow value on the edges from kids to school would indicate the assignment. We're going to take a quick diagram based on what this algorithm is saying. So the next thing is we should note that if an edge from VKI to VSI has a flow of 1, it means that the kid, that's KI, it means that the kid is assigned to school SI, right? And the assignment is a list or a mapping of kids to school based on the flow value. So let's take a quick diagram to show everything we just talked about in the algorithm. So we go from S, which is our source, and to T, which is the sink. Let's say we have n kids, right? We have n kids, and each kid would represent with k sub I. So we have one kid, let's call this k sub 1. The second kid, let's call it k sub 2, and we're going to continue that way, dash 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 dash, till we get to a certain number of kids. We can call this k5, and the capacity here is 1 because that's just one kid. So let's move this further. So we can move, let's call this whole setup T. So we can move, this is the sink, and we are going to be connecting the schools to the sink. So we have school 1 and school 2, and they go this way. So you have the sink, and the capacity would be 2. If we can see it in the question, it says to school 2 is 2. So the capacity, let's say the capacity of school 2 is 2, same for school 1, but let's say kid 1 goes to school 1, kid 2 goes to school 2, kid 3 goes to school 3, kid 5 goes to school 2. So you see, from this flow, only 2 kids out of kids 1, 2, 3 can get to go to school 1. And only one kid, K5, will go to school 2, since the edge T, KI, SI can only be 1. So I hope that makes sense. We're going to wrap up the video on network flow with this one, and from the next video we'll start looking at linear programming. If you haven't subscribed to my channel, please do subscribe. It's totally free.